All right, we got a full house, so thanks everybody for coming out. As you know, we got Rod Johnson. We're very thankful that he came out, and he's going to come and talk about Spring 2.5, and some of the stuff with the application platform. We got a few announcements kind of before we get started. We got the kind of QCon in San Francisco is going to be November 17th through 21st, and there's some flyers in the back that have some discount. I think there's $100 off. And this is a conference that's been around a while, but it's just starting in San Francisco. A lot of big-name speakers. Martin Fowler, Rod's going to be there, and maybe he'll tell you a little bit about it before his talk starts. Do we have any other kind of announcements? Turn off your cell phone. That's kind of a nice thing to do. Use the mic for your questions because we are recording, and you will be able to find this on YouTube later. Next month, September 16th, we have Mark Hansen, RESTful Web Services, so that should be a good talk. And special thanks to Google for allowing us, right? So that's all great. Well, Rod, go ahead and begin.
Thanks, Kevin. Well, I think actually I've been living in the Bay Area for about a year now, and I think this is probably one of the first public forums that I've spoken at here. So this is quite pleasing. Before I start, I'd like to just say a little bit more about QCon. If you're unaware of it, QCon is now I think in its second or third year. It's a conference that is in San Francisco. There's also a QCon conference in London, and it really is a very good show from a technology perspective. It's actually put together by a team of people led by Floyd Marinescu, who of course was the founder of Server-Side. And I mean, Floyd is obviously a guy who really does know his stuff technically. So, I would say that in terms of conferences for interesting technical content, it's definitely up there, and of course it is in the Bay Area. We will be presenting, I'll be presenting at QCon. Also, my colleague Rob Harrop, who's the lead of the Spring Source application platform, will be presenting. So it'll be a good opportunity to learn more about that. So what I'm going to talk about this evening is some of the new stuff in Spring 2.5, and also give a brief introduction to the Spring Source application platform. I was originally trying to do a Spring 2.5 update presentation in one presentation, and unfortunately it really doesn't work because there's just too much stuff that is new in Spring 2.5, so it ends up being a bit rushed. So what I've decided to do is to pick out one feature in particular and go into somewhat more detail about that. I'm very happy to take questions towards the end, so please, if you have a question about other things in Spring 2.5, I'll be very happy to talk about it. So the feature specifically that I'm going to talk about today is the annotation support in Spring 2.5. This is the biggest or the farthest reaching single new capability in Spring 2.5, but as I mentioned, there's quite a range of new features. Annotations, of course, should be familiar to everyone in the audience. They were introduced in Java 5, and they provide an ability to add metadata to source code. We started adding annotations to Spring in Spring 1.2. Those annotations were for enterprise services. So for example, we introduced the @transactional annotation, which was an alternative to external XML configuration for transaction delimitation. And we also introduced some annotations to drive JMX exposure of Spring managed objects. In Spring 2.0, we added further annotations such as @required for to specify required semantics for injected values. And also, of course, in Spring 2.0, we merged the Spring AOP model with the AspectJ model, which meant that we got the AspectJ syntax that was introduced in AspectJ5, where aspects could be defined in a very elegant annotation semantics within the Java language. In Spring 2.5, we go a step further and we provide comprehensive annotation support for dependency injection as well as enterprise services. It's probably worth talking a little about versions here. Spring has traditionally run on Java 1.3 and above. So obviously Spring first appeared before Java 5 was final. We then started in Spring 1.2 and 2.0 taking more and more advantage of Java 5 features. So in Spring 2.0 it still ran on 1.3 and above, but frankly most of the new stuff was only really relevant if you were using Java 5. In Spring 2.5 we've dropped support for Java 1.3. We still have support for Java 1.4, but again, if you want the full range of capabilities, you really need to be on Java 5. And we've started adding explicit support for Java 6. So there are a number of areas in Spring 2.5 where we take advantage of Java 6. Spring 2.5 will be the last version of Spring that runs on any version of Java prior to Java 5. So Spring 3.0 will be Java 5 only. And that, of course, means that certain of the core APIs we can modify and simplify to be purely Java 5. So why would you use annotations for DI? Well, there's a number of possibilities. You would apply annotations to classes, methods, or fields. If you would apply annotations to classes, you're probably indicating to the IOC container that this is an interesting type, a candidate for dependency injection and management. If you annotate a method, a field, or a constructor, you're indicating that that is a specific injection point, and you could optionally indicate something about how you should resolve that injected object. So the pros and cons about annotations for dependency injection. Obviously, this is a matter of some religious debate. We have taken a fairly cautious approach with annotations in Spring. So, for example, it's pretty clear in our view that annotations as the sole approach for dependency injection are not viable in the majority of enterprise applications. I mean, as I said, this is a point of religious difference. So, for example, I know that Google's own Bob Lee disagrees vehemently with this. All I can say is that Bob must have seen a different subset of enterprise application requirements than what I've seen, because there are a lot of situations where you need to externalize configuration from Java code. Certainly that's what I've seen and what we've consistently seen across our services practice at SpringSource. Annotations are obviously attractive in that they can reduce or eliminate external configuration. Annotations are inherently more concise. They're more concise because you're just defining what should happen. You're not defining where it should happen. Right? If you're using external configuration, you've got to have some kind of cross-referencing mechanism that ties that back to points in the source code. With annotations, you don't need to do that. You're at the point in the source code where something should happen. So all you need to do is indicate what it is that should happen. Some of the downsides are that annotations are per type, not per instance. That's a point that often seems to be missed. For example, in the framework itself in Spring, there are many generic classes, like some of the factory beans, that can be reused in many scenarios. And clearly, it's not appropriate to use annotations on those types because they can be reconfigured in different ways with different external parameters. Similarly, it may be a problem if you have existing code, for example, somebody else's library that you don't have the source for. So it's very valuable to have a strong method of being able to configure that without getting hold of the source code. Obviously, you may not want to recompile it. And there are scenarios where you can, for example, externalize not just into XML files, but into property values. So people who are not Java developers can modify the behavior of your application, and that can be really quite useful. Also, annotations don't tend to be a good technique or approach for externalizing simple types. We have two choices for annotation-driven dependency injection in Spring 2.5. The first is the @AutoWired annotation, which Spring introduced itself. The second is the AtResource annotation, which was introduced in Java EE5 and is associated with EJB3. Of the two, we recommend @AutoWired. The reason that we recommend @AutoWired is, I think it's fair to say this is a third generation approach to annotations for injection. So, for example, if you look at the AtResource mechanism, it was the first attempt to apply annotations for dependency injection. Then Juice came along. Juice really had some pretty nice ideas, and we had the benefits of both those inputs into the design of @AutoWired. As the name implies, @AutoWired builds on Spring concepts. Auto-wiring is a term that Spring has had since Spring 1.0, and it's an approach in which the container has always been able to figure out the necessary injection behavior through introspection. @AutoWired can be applied at constructor, field, or method level. Like Juice injection, it supports multi-argument methods, which also helps to make it very concise. The default behavior is Spring's traditional auto-wire by type. Annotations make auto-wiring much more useful. So traditionally with Spring, you could have a bean definition in XML or otherwise externally defined, and you could apply auto-wiring to that bean definition. The problem with that was that it was an all or nothing approach. So the container would then look at your constructors and look at your setter methods, and it would try to resolve everything that was injectable by other managed objects in the current IOC container instance. That was useful, especially in prototyping, but when you got into complex scenarios, it could be a problem that essentially it was going to try to process all your setter methods rather than be strictly targeted. With the @AutoWired annotation, in the simplest form, you just annotate the fields, methods, or constructors that you're interested in. And the auto-wiring behavior will only apply to those methods. So you can have other methods, other setters that won't be processed through auto-wiring. This is the simplest form of usage, and this corresponds to Spring's auto-wired by type. How many people are using Spring? How many people are using auto-wire by type? Interesting. How many people know what this will do? So if this is the same behavior as auto-wiring by type, what will it do? It will inject it, yes, I would hope so, but how will it inject it? How will it resolve the injection? So clearly we've got two problems here, and actually that's a valuable point because what you've identified is one of the two problems, which is injection. So we're identifying something that will be injected. The second part of the problem that we need to solve is, yes, it will be injected, but where do the values that we need come from? So there are two distinct problems. The problem of where do you inject, and the problem of, okay, how do you resolve what it is that you need to inject? So with respect to the second problem, how is the container going to try to figure out where to get those references from? From the Spring context, yes. And how is it specifically going to work out? By type, exactly. So this will work if we have exactly one data source and exactly one connection factory in our Spring context. It doesn't matter what they're called. For auto-wiring by type, bean naming is irrelevant. So in other words, it's exactly the same behavior that Spring has always had. The difference is now we can apply it selectively. So it's a good, simple approach. However, what happens if there are too many candidates? So for example, what happens if we don't have just one data source for one database? We have multiple. Well, in that case, resolution by type isn't going to work. So we need to provide hints. And Spring provides a mechanism of doing this called qualifiers. So qualifiers can be used on fields or parameters to narrow down the resolution. So here we see a slightly more advanced example where we have at AutoWired identifying that this method is an injection point. And now we have 3 parameters. So firstly, note that the number of parameters and the name of the method are irrelevant. So you can have any number of methods, any number of parameters that you want, and the method can be called anything that you like. The interesting thing here is that we've got ambiguity, and how we're resolving that ambiguity in this case is through resolution by name. So what we're doing is we're using an additional annotation on the parameters to say that this should be resolved to a particular named bean in the current Spring application context. The third value will be resolved using the default AutoWire by type. You can mix and match, so you can have as many different modes of resolution as you want. They're all processed independently. So this is exactly the same as Spring's traditional AutoWire by name. We can also resolve dependencies by annotation. So clearly that approach involves putting the knowledge of the names of your Spring managed objects in your code, which you may or may not want to do. If you don't want to do that, another approach to do it is to resolve dependencies by annotation. And this is the approach that was pioneered by Juice. So here what we're doing is pretty much the same as what Juice does. This is analogous to @inject. And here we're having annotations that are user-defined annotations and not Spring annotations that define how you resolve those values. It's a bit different to Juice in that you're not tied to specific annotations. Actually, I think a guy called Solomon Duskus, a consultant in New York, blogged about how you can get Spring just without changing any code to process Juice annotations because you can just configure the kind of annotations it scans for. So here, what we're going to say is that we've got 2 order services. We're going to resolve the potential ambiguity by saying that this order service is resolved to the order service instance that's associated with the @amir annotation, and the other one is resolved to the service order service implementation associated with the @apac annotation. How do we associate it? Well, there are 2 ways. One is to annotate the reference, the type that you want to be resolved to with the annotation that it should be associated with. So for example here, we could define the @amir annotation, and we could annotate that the order service type that we want to resolve to here with that annotation. So it's exactly the same as the Juice model, basically. It also has the same downside, which is that defining annotations in Java is pretty verbose. So you do need a separate artifact for each association that you wish to create. The alternative approach is to do the association in a bean definition. So here you can specify a qualifier. It's a new sub-element of the bean element, and you just specify the fully qualified name of your annotation. This works nicely if you want to use annotations, but you don't want to annotate the target. The bean definition, by the way, with the annotation model, as you will see shortly, is optional. So you can define beans without any annotations. So let's go back over this again. We use annotations to identify injection points, the @AutoWired annotation. We can have the default behavior of AutoWire by type, or alternatively, we can resolve by name with the @qualifier annotation, or we can resolve by annotation. We can associate the injection target with the annotation in one of two ways. We can annotate it with the annotation, or we can create the association in a bean definition. All this, of course, is additional to everything else that Spring does. So you don't lose any capabilities. These are entirely new capabilities. AutoWired, AtAutoWired, pros and cons. It's a very capable model. It is simple and concise, works with arbitrary method names. You can have any number of parameters. You can mix and match resolution approaches. Really, the only negative is that it's a Spring-specific mechanism. You can, if you're really bothered by that, you can configure Spring pretty easily to use your own annotation instead of AtAutoWired, but frankly, that's probably a slightly puritanical objection to using something that's useful. The alternative approach that we ship out of the box is AtResource. AtResource is a Java EE 5 annotation, and it identifies an injection point that can resolve to a single component. In Java EE 5, any top-level component like a servlet or an EJB can have AtResource used on it. Interestingly, in WebLogic 10, the implementation of AtResource has always been based on Spring, using the Pitchfork project. But in Spring 2.5, Pitchfork is not required on top of Spring to do AtResource injection. What it gives you is essentially a superset of what you get in Java EE 5, because Spring removes the restriction that the component should come from JNDI. If you're using AtResource for injection in a servlet or an EJB, the injection target must come from JNDI, which kind of makes it not so useful for injecting fine-grained objects. We remove that objection. That restriction looks exactly like what you would see in EJB3 examples. Spring does that out of the box. You don't need anything additional to Spring. Pros and cons. It supports Java EE 5 behavior. So, it does help theoretically with portability. You could write this and you could potentially run it in a Java EE 5 environment. But bear in mind, you could actually run your Spring in a Java EE 5 environment anyway. So, that again is largely theoretical. The problem with it is that, frankly, it is a first generation attempt at annotation injection, and it really does show. So you can only inject one reference at a time. There's no sophisticated support for qualifiers. And bear in mind that if you really want it to be portable, you have to be committed to making every single object that you're going to inject exposed in JNDI, presumably as an EJB. So we don't really recommend that. It's a nice checkbox feature to have. It's also something that will probably be very useful when a little further down the track we expect to make the SpringSource application platform implement EJB 3.1 Lite so it can get Profile A and B certification for Java EE 6. So then when we're implementing EJB 3.1 Lite, clearly having quite a bit of it already in the Spring framework will be very useful. There is, however, something in Java EE 5 that we think is very useful in component management. And that is the @PostConstruct and @PreDestroy lifecycle annotations. These are really analogous to Spring's init methods and destroy methods, and also the initializing bean and disposable bean interface. We think this is a best practice. Annotations are an elegant approach to doing this. This is supported in Java EE 5 environment as well. So we really recommend that you use these annotations rather than the Spring-specific techniques, if you can, to achieve that kind of lifecycle behavior. Again, supported out of the box in Spring 2.5. You do need to enable the support. All the code you need for it ships out of the box, but you do need to use a specific flag in your configuration to enable it. The reason for that is otherwise it would break backward compatibility. Because if you had some classes that happened to have those annotations but you didn't expect them to be used in Spring, clearly it would be a problem if suddenly Spring started calling methods you didn't expect. So that's the only reason, in case you're wondering why a clearly desirable behavior is only an option rather than the default, it's because it would break backward compatibility, because otherwise, it's probably a pretty weird scenario. But one thing that we've seen is that if you have millions of downloads and hundreds of thousands of users, it doesn't matter how weird the case is, somebody is going to run into it. And potentially this could clearly be quite a hard puzzling problem for someone to track down. So we recommend that this is a best practice and you adopt it. Right, I talked about the way in which you could apply annotations at type level, at method level, field level, and constructor level. I haven't shown you any examples of annotations at type level. Why would you have annotations on classes or interfaces? The reason that you would do that is twofold. You could annotate types to indicate their purpose in an architecture. So a form of documentation that's available at runtime through introspection. You could also annotate classes to indicate that they should be picked up by the container. So here we come back to something that we introduced in Spring 2.0, which is the notion of stereotypes. In Spring 2.0, we introduced the org Spring Framework.stereotype package. These identified classes that had a particular purpose in your architecture. Really, there's nothing there that's particularly Spring specific. I mean, it's meant to be at a conceptual level rather than a specific implementation level, but there wasn't anything else out there that had actually defined what we wanted, so we put them in Spring. Why would you want to do this? Well, firstly, it might make your code easier to understand. It's a form of documentation, and documentation's a good thing. Documentation is a particularly good thing when it's amenable to tooling and when it's accessible at runtime. So that's one reason you might want to do it. Another reason is that it's a very good target for AspectJ point cuts. In AspectJ 5, there was introduced the ability to select join points in point cuts based on annotation. So this is a form of documentation which actually enables you at runtime to pick that out using an AspectJ point cut. So for example, think about, you could write a Java doc that says something like, this is a Spring MVC controller, or this is a class that runs inside the something or other engine. And that would all be fine, but it's not useful to you at runtime. If you use an annotation for it, you can now easily write point cuts that you can use in Spring AOP or AspectJ that will pick it out. We ship a number of annotations out of the box in the org Spring Framework.stereotype package. We ship @service, which identifies a stateless service. @repository, which uses domain-driven design terminology. It's essentially what we often call a DAO or DAO, depending on your religious preference. There's a lot of religious preferences in programming. @aspect, which is, of course, not an annotation that we introduced, but an annotation that AspectJ 5 introduced and we adopted. And @controller, which is a Spring MVC controller. So all of those ship out of the box. However, now I'm going to introduce the concept of meta annotations. Meta annotations are annotations that annotate other annotations. I love saying that sentence. I never get tired of it. It's the kind of thing, you know, late at night in a bar, having a contest to repeat that would really be very entertaining. What is a meta annotation? Well, annotations are basically pretty messed up in Java. I've referred to the idea of first, second, and third generation annotation-driven injection models in Java in the assumption that each generation is probably going to improve on the last. Annotations in Java were really second generation in that they'd already been introduced into .NET. So it's kind of a bit disappointing that they're probably not as good as .NET had already done. One thing that really is a bit weird is that annotations can't participate in inheritance hierarchies. Given that the things are only dynamic proxies at runtime, I doubt there's any really strong implementation argument against that. But it certainly causes a significant number of problems in practice. How many people have authored annotations? Okay, we're already down to a pretty small subset, so I'm not so confident about the answer to the next question, which is when you author annotations, you pretty rapidly hit the point where you actually realize that you have 3 or 4 annotations that share some properties, and it's like, oh, I need to duplicate. And I need now to duplicate the code that populates those properties. So because annotations can't participate in inheritance hierarchies, there is no way to express an ISA relationship. So for example, a Spring MVC controller is a type of component. A service is a type of component. So at the top level, we've got this. The only way to express that notional inheritance relationship is through annotations annotating other annotations. That is possible, and that really is a nice feature of annotations. So, with the @component meta annotation, you can go and create any other annotations that you want that are annotated with @component. Now that is very interesting because that means that you can actually tell Spring to go and scan the class path to find any annotations that are annotated by the @component annotation. And that enables it to pick up classes that should be Spring managed objects or Spring beans without a requirement for any XML or external configuration. So, let's suppose you have an @service on a class. This is an @component because it's annotated with @component. All you need to do is configure annotation scanning, and it would be equivalent to this. So if you turn on annotation scanning, as soon as Spring looks at the class path, it will hit this, and even if there isn't this bean definition, this is what it will implicitly create. Remember that Spring's internal metadata is not tied to XML or any other representation. So there's no need for XML or a particular format of external metadata for Spring to manage objects. How do you set it up? Well, again, this is something that isn't switched on by default. Again, if we switched it on by default, you would get some pretty strange potential behaviors in existing applications. So you use a new namespace called context that is used to configure things like annotation scanning for both component level and injection. And you just specify which package or packages that you want Spring to scan on the class path. Obviously, it's a good idea to be reasonably specific about that. Because annotation scanning, if you're scanning the user-supplied types of a particular application, is going to happen pretty fast. But for example, if your base package was COM, that could be a problem because it could try to scan some of your third-party libraries. So use common sense, and if you use common sense, you really will not notice the performance impact of the annotation scanning. Obviously, a naive approach to annotation scanning would be to go and look at the .class files that you could get hold of and actually do a class name to look at the annotations that they might contain. Why would that not be a good idea? Okay, you guys are application developers rather than infrastructure developers. You are normal people. You are not the weird, twisted, disillusioned people that write infrastructure. It would be the ideal and obvious way to do it. Unfortunately, if you did that, you would be loading classes eagerly, which can cause all kinds of nasty problems. Good example of this is instrumentation. So for example, if you're using the Java Persistence API, your implementation may need to instrument entity classes. So at entities, it may need to instrument to do lazy loading. If you load them too early, so for example, if Spring, which probably bootstraps your JPA implementation, also goes and eagerly scans every class in your application, that's it. You can't take a class out of a class loader. So once it's loaded, it's impossible for anything else to instrument it. There's also things like the initialization of statics. There are a bunch of reasons that you can't do that. So what we do is we actually use ASM. We have our own abstraction for metadata. So we have our own abstraction for Java class definitions, and we load it using ASM. So it does not cause any class loading problems. It also means that in the remote event that any of you do become warped and twisted infrastructure developers, it's a pretty useful library for getting information without being tied to ASM or a particular implementation. So that's the simple way to turn it on. This is probably what you will use. It will, of course, look in jar files, etc. It's not just going to look at .classes. And you can, this being Spring, you can configure it to your heart's content. So let's suppose you want to suppress the default filtering. By default, when we go back here, we're saying, where are we going to look? We're going to look in the My App package. It will look in jar files, it'll look in .class files. So it'll look all the places you would expect it to look. But implicitly, what it's going to do is look for @component annotated classes or for @aspects. That's what it's going to look for by default. If you want, you can turn off the use default filters. You can filter by your own annotation. You can filter by regular expressions, and you can filter by assignability. So for example, you can find all implementations of a particular interface and automatically pick them up. So for example, if you want to differ between test and production, you can pretty easily set something up so that everything that ends with stub is picked up in a test environment but is not picked up in a production environment. Doesn't have to be purely on annotation. Similarly, the ability to include or exclude based on assignability can be very, very useful. I think this is a feature that people probably don't realize the power of. You can do some very interesting stuff. Like when I was first playing around with this in one of the milestones of Spring 2.5, I was looking at how you could do production and test auto selection. I mean, it was just amazing how easy it was to use the includes and excludes to get that working. Pros and cons. You can wholly get rid of XML if you want. If you want to write a Spring application without a single line of XML, you can do it quite easily. Changes are picked up automatically. That's particularly nice during development. So, you add a new type that you want picked up, it just automatically gets picked up. It works particularly well with annotation-driven injection. So if you didn't have @AutoWired, it would be something of a scattergun approach. With @AutoWired, it works extremely well. And as you've seen, it is highly configurable. So, it doesn't just work in the easy cases, it works in corner cases as well. Obviously, as I said, no annotation-based approach is a 100% solution. You do need to use common sense so that you don't scan an excessive number of classes. And one downside is that external configuration can give you a valuable blueprint of your application structure. And you don't get that. If things are being picked up and linked by annotation, you don't get a single place or single set of places where you find a blueprint for your application. Fortunately, there is a solution for this. As I said, it's all Spring metadata in the end. So the Spring component model internally in the container does not know anything about XML or annotations or any other representation. So this means that one approach doesn't exclude others. Essentially, what happens is the container starts up, it reads whatever configuration it should read, it reads whatever properties files it should read, it scans for whatever parts of the class path it should scan for, and then it merges it all together as contributions to a single Spring application context. This means that it's perfectly possible to mix and match XML and annotation configuration. So you never hit a wall. If you have a problem where you want a particular behavior you can't get with annotations, you just write an XML bean definition for that particular bean. There is a pretty simple naming convention, which is the decapitalized short name of the class. Alternatively, if you want any of the @component annotations, you can supply a name for as well. That's something to bear in mind if you're defining your own annotations that you're going to annotate with @component. Be sure to provide a name property. Again, inheritance does not work for annotation, so the fact you're annotating it with an annotation that has a name won't do you any good. You need to supply a name property, and then you can get that resolution by name working as well. So you can provide combine the best of both worlds. If you want that application map, you can actually even get it with a mixture of annotations and anything else you like if you're using Eclipse and Spring IDE. How many people are using Eclipse? How many people are using IntelliJ? Yep. Oh, no, it's not everyone else. How many people are using something else? What is it, NetBeans? JDeveloper. NetBeans? JDeveloper? VI, wow. I used to use VI. So if you're using Spring IDE, an Eclipse plugin, you will get a unified view of configuration. Also, I do know that there's been a lot of improvements recently that the JetBrains guys have done in IntelliJ. I don't know what the status is of NetBeans or JDeveloper. Okay, now let's move on to Spring Web MVC. Firstly, any questions about that? Is everything that I said clear?
One question. Does the XML override the qualifier-based AutoWired?
Yes. The XML will override annotations. Which makes sense because obviously you can change it more easily. However, in general, I would say if you need to use the XML to override annotations, you'd want to ask why you're putting the annotations in. It's probably a bad place to use annotations because obviously it becomes confusing. I mean, some people might look at the source code and be very surprised to see a different behavior. Okay, on the theme of annotations, let's now turn to Spring MVC. Spring MVC is basically a very powerful MVC framework. It has always offered a flexible model. It's always had a host of extension points like handler mappings, handler adapters, view resolvers. Every part of it is customizable. It really had two problems. One was that it required excessive configuration to set up. We started to ameliorate that in Spring 2.0, but I mean, still, it required a little bit too much configuration. And also the hierarchy of form controllers never quite felt right. Never quite felt right because it was based on concrete inheritance, and concrete inheritance sucks. So, I mean, I actually was responsible originally for designing that, and I must admit I never felt that it felt right. It was certainly a great improvement from struts, on struts, but, you know, then as most things in life. So, with the inheritance hierarchy, you had simple form controller and all the others, and it got complex. You had to understand quite a bit about what order particular template methods were going to be called in. And fortunately, this is something to which annotations are a natural solution. Annotations are a really, really, really big deal for MVC. In fact, interestingly, annotations seem to have given Spring MVC a new lease of life. So, you know, the take-up of Spring MVC in the last year has actually been very, very substantial. And what it meant was that we could get these kind of effectively callback behaviors without being tied into a concrete inheritance hierarchy. This has a number of benefits. Firstly, it means that you get your inheritance hierarchy back. So you get away from one of the problems that, you know, plagued a lot of frameworks in the past. You've only got one shot at concrete inheritance in Java, and you better make good use of it. So that's a benefit for you as developers. There's another benefit for us as infrastructure developers, which is that if you're not tied into concrete inheritance hierarchy, your code is much more decoupled from our code. We actually want your code decoupled from our code, because that means that we can modify our code without breaking your code. So we can modify our code and potentially make you happy rather than unhappy if we modify our code to make it better. So if you use Spring MVC, you might have been familiar with multi-action controller. How many people have used Spring MVC? Multi-action controller was similar to Strut's dispatch action. So it enabled you to have multiple methods in a controller that could handle different request mappings. The problem is, without annotations, you needed to have external configuration to resolve which methods get mapped. And also, it didn't really work at all for complex form processing without annotations. In 2.5, you simply annotate POJOs with a number of annotations like @controller, which is an @component annotation that identifies a controller, @request mapping, @request param, and various other annotations. Let's look at a simple example. So here we have @controller. This can cause auto scanning, component scanning, to pick up this as a controller without any XML. In Spring 2.5, you should not be defining XML beans for your Web MVC controllers. Why should you not be doing that? You should not be doing that because you only need bean definitions for more complex things. If there is something so complex about your MVC controller that annotation-based dependency injection is insufficient, you really need to think about your design. Because if your web tier is that complex, you should be trying to push down responsibility to the middle tier where it's more reusable. So we're specifying here the @request mapping. So it's going to map to order, the virtual subdirectory for order. At AutoWired here, we're injecting a field. We're injecting a private field In general, I'm not a fan of field injection because it's untestable. In MVC controllers, it depends on whether you want to unit test them. If you want to unit test them, you probably should use a method or a constructor. If you feel it's acceptable not to unit test controllers, then field injection would be fine. Here, we're specifying a particular request mapping, and this actually ties into some behaviors for particular well-known values that can be passed into these methods. So here, we're returning void. A void return type means that you're going to work directly with the request and response objects. So if you pass in the request, a request parameter, it will obviously populate it with the current request. If you pass an output stream, it will get hold of the servlet output stream, so you don't have to unwrap it yourself. So what it will expect is that you write directly to the output stream. In general, what you will want to do is return either a string, which will be the name of a view, or a model and view object, which is the kind of model and view abstraction that Spring MVC has always provided. So if you're returning a view name here, this is a bit like web work where you're returning the logical view name. And you can, of course, if you want, add values into your model. You can use annotation matching to populate your parameters, and these include @request param. So obviously this just gives you a taste of it. There are a whole bunch of rules around exception handling and the like, but as you can see, this is way, way more concise than was possible with Spring MVC in the past. You literally don't need any XML in a case like this for your web tier, because you're specifying the request mappings, you're specifying the URLs, you're doing all of this with annotations, and you don't need bean definitions either. There are also annotations for session attributes, data binder initialization. Have a look at the Pet Clinic sample application that ships with Spring. This comes to an interesting question we sometimes hear. Sometimes people say, well, as Spring gets more and more complex and does more and more things, isn't it going to go the way of Java EE? And the answer is no. Just because other people have made engineering mistakes in the past doesn't mean that everyone has to make the same mistakes. In fact, you would rather hope that people learn from the mistakes. So if you compare the examples that ship with Spring 2.5, have a look, for example, at the Pet Clinic that ships with Spring 2.5 versus the version with Spring 1.0. I think it's something like 70% of the code and probably 20% of the configuration. So the reality is that with each version of Spring, it does become more capable, but it also becomes easier to use. The world of Spring is not purely about the Spring framework. Obviously, the Spring framework is the thing that everyone is familiar with, but beyond the Spring framework, there's what we call the Spring portfolio of open source projects. This extends beyond the Spring framework to a variety of the important problems that you meet in enterprise Java development. These include Spring Security, which used to be known as a CG security, Spring Batch, Spring Webflow, which is a higher level framework for web development, Spring Web Services, Spring Integration, and Spring Dynamic Modules for OSGI. We had a major release back in April where we had a number of releases across the portfolio, including the first release of Spring Batch, Spring Webflow 2.0, and Spring Dynamic Modules 1.0. Good example of the kind of things that we're trying to do thematically is a CG security for Spring. Someone, I think it was Dan Deephouse, wrote a marvelous blog. It was a very short blog I think the entire blog was every time you use a CG security, a fairy dies. But it's still the best there is. It was a very short, very depressing blog. So fortunately, when Dan wrote that blog, Ben Alex, the lead of Spring Security, was already busily at work on a solution. This solution also, by the way, solved another problem about a CG security. The other problem was how to pronounce it. Many people ask how to pronounce it. In fact, I didn't know the derivation of the name for quite a long time. Being Australian and knowing that Ben's Australian, I thought, it sounds kind of a little bit like a native word, but it's actually not. It doesn't mean anything at all. It's the first, third, fifth, seventh, and ninth letter of the alphabet. So, a CG configuration was undoubtedly somewhat toxic. So to configure a simple web application, you would write that XML, this XML, and this XML. It was about 140 lines. Obviously, a CG security exhibited the majority of the characteristics that are good about Spring. It was extremely powerful, it was extremely good quality, very well tested, very robust, incredibly flexible. There really aren't that many things that you can think of that you'd want to plug into for credential stores or the like that it couldn't work with. But it didn't really quite make it on ease of use. In Spring Security 2.0, which is the Spring branded successor to a CG security, it introduces a new namespace. This namespace came from the namespace extension capability that was introduced in Spring 2.0. And it means that configuration now can use far more aggressive defaulting, and this is now the minimum configuration for a CG security or Spring security. So very, very much easier to adopt. Another interesting feature about this is that you'll see that the default namespace here is not the beans namespace. Using XML schema, you can make the default namespace whatever you want. So you could put beans in it if you wanted to, but we've made the default namespace to be the security namespace. Everyone understand that? So if you write your own namespace extensions or you use some of the ones that ship out of the box, you can actually, if you want, reduce clutter by making them the default namespace. So Spring Security had a very major advance in 2.0, and this is the kind of thing that we're trying to do across the Spring portfolio, is not just add additional capabilities, but try to make everything as easy to use as we can. Now I'm going to move on to giving you a brief taste of the Spring Source application platform, which is a product that we announced fairly recently. This is an application server. It is completely module-based. It builds on Spring, Tomcat, and OSGI, specifically the Equinox implementation of the OSGI specification. But on top of that, we have a middleware kernel that we call DM kernel, or Dynamic Module Kernel. I can see that there's one Spring Source application server or application platform t-shirt in the audience. Thank you. Very thoughtful. We gave away quite a lot of those t-shirts at Java 1. So why does Spring Source application platform matter to developers? Well, firstly, it matters because choice is good. Spring is inherently portable, and that's great. That's one of the reasons that it has become so popular. However, it's always a good thing to have additional choices in where you can host your Spring-based applications. But it's also beneficial in that there are a number of problems that really have not been addressed very well in enterprise Java to date. For example, shared library conflicts, class loading. These really are areas of great pain in traditional application servers. For example, running Hibernate 3 in WebLogic 8.1 or WebLogic 9 could actually take the server down. It didn't actually take the server down when you started up the application. It took the server down when you ran the first query. Why was this? Well, first thing to note is it really wasn't a problem in either WebLogic or Hibernate. I mean, WebLogic's a pretty good product. WebLogic is pretty hard to take down. The problem was that WebLogic internally used Antler, and Hibernate 3 used Antler. Hibernate 3 upgraded to a version of Antler that was completely incompatible with what WebLogic was using internally, with the result that it made WebLogic actually exit. The exit message was quite amusing. It said, system error, char scanner panic. So the reality is that these kind of problems are firstly not necessarily anyone's fault. So you can get the fairly scary situation where you've got two vendors, neither of whom is really doing anything wrong, but the end result being problematic. And they're becoming more and more frequent because every application server now has open source used in it. Pretty much all applications have open source used in it. So there are really only two ways to go to resolve it. One is to do various kind of hacky solutions. So you could invert your class loading with so that a Web XML, for example, loaded its version of Antler in preference to the WebLogic version. But you know, in complex scenarios, they don't always work. Or alternatively, you can adopt hacky solutions like jar, where, for example, if you have a look at the use of Spring and in WebLogic 10, it's actually repackaged as com.bea.spring. And the reason they did that was if they didn't do it, potentially the Spring version could conflict with people using Spring in their own applications. So there are a bunch of problems around class loading and versioning that are really only getting worse with time. In the Spring Source application platform, we actually apply the power of OSGI for a strategic rather than hacky solution to those problems. So that's a very important benefit. But we also allow the modularization, not just of the server, but the modularization of your applications. So you can divide applications, large applications, up into different modules, and you can replace parts of your application at runtime without taking the whole application down. The long-term vision of the Spring Source application platform is not just to play in the space of the J2EE server, but to provide a middleware underpinning for a variety of infrastructure contexts. So, for example, the ability to have, say, an ESB, to have a batch server, as well as the traditional web-oriented application server scenario. Essentially, this is completely consistent with the vision that we've had for a number of years. So, for example, if you look at J2EE without EGB, which was written back in 2003, one of the things that I argued for that was a kind of server a la carte, where you just take the pieces of the server that you wanted. Well, the combination of OSGI and the DM kernel that we've built on OSGI makes that possible. Some of the benefits you can get is that you can avoid conflicts. So if you have dependencies on incompatible libraries, you can actually make that work because of the isolation that you can get with the OSGI model. Because the server is modular itself, it has a very small memory footprint. The memory footprint of the core DM kernel is about 12 megabytes. This compares, I think, to something like 700 megabytes for WebLogic and something like 90 for JBoss. So it's a dramatically smaller kernel than existing solutions. And where we think that there's a lot of potential for this kind of small footprint, very flexible product in tomorrow's environment of virtualization and increased interest in SOA. The Spring Source application platform is about to go version 1.0 final. The present version is 1.0 RC1. Development on that product's pretty much, well, it is actually finished for 1.0. It supports, at this time, 3 deployment units. One is standard WAR deployment, which we all know and love. Well, we all know it, we may or may not love it. The second is, well, essentially it takes 3 kinds of WAR, a native web module, and what it calls a PAR. A PAR is a platform archive. So this is a particular kind of deployment unit that contains 1 or more OSGI bundles. A web module is a kind of OSGI bundle whose metadata will tell the application platform to process as for web artifacts. The easiest way to get started is probably to look at the WAR support. So this gives you an interesting migration path where you can examine whether or not the Spring Source application platform is for you. So you can start off by taking a standard WAR, which should run. Then you can, if you want, say, the biggest problem with my WAR is the shared library hell. So imagine you've got, these days in your WAR files, it's not unusual to see some of our customers with WAR files that have got like 60, 70 megabytes of third-party dependencies in the lib directory. There's a number of problems with this. One is that the deployment artifact is simply too big. Let's suppose you want to update 10 servers. Well, that's like pushing out 600 megabytes. Secondly, what happens if you want to make an update across numerous applications? There's no clean way to do it. If you try to move some of those third-party dependencies to your server, like for example in the Tomcat lib directory, you can actually run into some class loading problems. And you can also run into conflicts because now they're accessible across all applications, and some applications may depend on different versions. So the first step down that track to resolve that is what we call a shared library WAR. So you keep the structure of your WAR deployment unit, you keep webinf classes, webinf, web.xml. You just get rid of everything in the lib directory. Instead, you actually write a meta-env manifest file that specifies the dependencies, which can be resolved by the server. Let's have a look at an example of this. It's a very easy option. We get rid of all the CRUD in the webinf lib directory, and we write something like this in meta-env manifest.mf. By the way, I'm not sure that everyone knows that a web module, so a WAR deployment unit, can have a manifest. There are actually things that you can put in a standard WAR that you specify in the manifest. So here, what we're doing is replacing the webinf lib by import library and import package statements. Import package is pure OSGI. So this is an OSGI bundle concept. However, import package can be actually pretty fine-grained. Obviously, you could go crazy trying to express the dependencies for, say, Spring or Hibernate using import package. So in the application platform, we provide a higher level of directive called import library. So here, you can say that I depend on Spring, and I depend on Hibernate and the EJB JPA support in Hibernate. So, note what we can do is we can specify the version. So if we have 2 applications or 3 applications running in our server that need different versions, that's fine. They can specify different versions. We also take care of the transitive dependency problem. As you know, if you use Hibernate, Hibernate has many friends that it requires. friends like CGlib, like Commons Collections, and even some of the more obscure ones like JTA. So the import library directive takes care of that. Where do the dependencies go to be resolved? Well, the platform will look in the repository, the provisioning repository of the Spring Source application platform. The provisioning repository you can populate through the Spring Source bundle repository. So that's a free online resource where you can go and you can search for example, the Spring or Hibernate or loads of other libraries that you might want to import. So if you apply this, you can get a pretty big saving in the size of your WAR files without changing anything else. So for example, when I tried it with one of my own sample applications recently, which was a very simple application, I think it went down from something like 20 megabytes to 500K. So that can be a benefit, and obviously the benefits of the robust versioning and the transitive dependency management can be very significant. Okay. So the question is, why do I specify this version range for EJB? It basically, I think, would be equivalent to just 3.3.1. I don't think that a range that actually has the same value actually means anything. However, you can actually use ranges if you want. So for example, if you know that it will work with, say, Spring 2.5.3 or 2.5.4, you can put a range in that. And that could be useful because you don't want your provisioning repository to have versions of something that you don't need.
In this case, since this.ga is not a numeric value, is Spring Source able to determine the order of say.ga with a .1?
Sorry.
Determining this range.
Yeah, it's Spring. The platform can actually look at the versions and it can work out by the conventions, which is the most recent version. So the provisioning repository therefore becomes part of the server. Clearly, it makes sense to move libraries into the server rather than the application, right? If you think about J2EE, J2EE was meant to provide common infrastructure. It was meant to be everything you need. But it didn't actually work like that because what happened was we started to put 20 megabytes of Apache stuff, Spring stuff, Hibernate stuff, etc., to actually make it usable. And then we deployed that with every application. We couldn't actually move it to be part of the server because then you got version conflicts from hell. So when you have versioning, moving it to be part of the server makes obvious sense. And therefore, you get sharing between applications. So that's a very easy way to try the platform. The next step is shared services war. So that's a shared libraries war. Shared services war enables you to share OSGI services. And you can share them between applications. So for example, if you want something like a data source, if you want a shared service that is accessed by many applications, you can actually do that between bundles. And now you get the ability that if you redeploy your library application with a shared service, the dependencies are on it. You don't need to restart all the other applications. So there's some pretty nice benefits there. Then there are the native deployment units, which are themselves bundles. So there's a very interesting migration path. The present deployment units are web-centric. So presently what happens when you start up the Spring Source application platform is you get the DM kernel booting, which boots Equinox, works with its provisioning repository, and then for the administration console and the default web deployment unit, it starts up our version of Tomcat within the application platform. However, Tomcat is just a part of the platform. So it's not Tomcat that boots, it's the application platform that boots, and it uses Tomcat to do much of the war deployment. We actually replaced some parts of Tomcat, so we have a more robust threading model than Tomcat provides out of the box. But the fact that Tomcat is a subsidiary rather than the bootstrap is very important, because future deployment units will offer things like batch deployment with Spring Batch, integration deployment with Spring Integration, and we also see a possibility for partner deployment units. So this means that literally you can have just the server that you need to run a particular scenario. You can access in the server, you can see what bundles are currently in use, etc., in terms of the server's administration console. Okay, I think we'll try to get to the rest of the presentation, then I'll take questions. I'd like to say a little bit about SpringSource. Obviously, everyone's familiar with Spring. Not everyone is familiar with SpringSource as a company. We are the company behind Spring. Pretty much every significant Spring committer is either an employee or, in fact, in many cases, a founder of the company. Our customers worldwide include over half of the Fortune 500, and we have well over 100 people worldwide. We acquired in January 2008, we acquired Covalent Technology. This, interestingly, means that we are the leading provider of support for Apache technologies such as the Apache Web Server and Apache Tomcat. So we have hundreds of customers that we support on Tomcat in particular. So this, of course, is very important in terms of the application platform offering that we have some of the core committers on Tomcat. Actually, an interesting metric of Tomcat, in the last 12 months, 83% of commit activity on Tomcat came from SpringSource employees. So, it isn't just about Spring. We are really extending ourselves to provide a very strong overall offering around enterprise Java. We provide strong technical leadership, and we're very committed to our vision of simplifying development and operations. It isn't just about Spring, and it isn't just about the SpringSource application platform. If you looked at a legacy production environment, typically you had an application that was very tied in to the platform. With Spring, Spring not only provides a development framework, but it actually provides significant parts of runtime functionality. So Spring is typically managing things like security, transaction management, many things besides configuration, and this makes applications increasingly portable. So when we talk about the SpringSource application platform, it's important to note that this is an additional choice. It's not something that, if you're using Spring, you need to use. Obviously, we would like to make the SpringSource application platform the place you would want to run Spring applications, but we're absolutely committed to ensuring that whatever server people are on, Spring will be the best way for them to develop and run their component model. SpringSource sells a number of products and services, including, as I mentioned, support for Apache technologies, including Tomcat, the HTTP web server, and ActiveMQ. We also provide a product called SpringSource Enterprise, and I'll just say a little bit about that. SpringSource Enterprise has three elements based around Spring Framework and the Spring portfolio. The Spring Enterprise Edition gives you a version of Spring where you're guaranteed to get bug fixes, and you're also guaranteed to get instrumentation for better application management. So obviously, with open source software and Spring, like everything else, the focus of the committers is normally on the latest and greatest. So for example, now the current version of Spring, it was 2.5.5, I think, and that's the current focus of activity. Of course, for smaller companies, that's just fine. They don't particularly care about anything they can't get in terms of just the community releases. For the enterprise, very often people will find that they're doing, for example, 12 to 18-month cycles. They're very large projects. They start on a version of Spring or other open source software at a particular point in time. By the time they roll it out into production, that is no longer the latest major version. And it really is not an attractive option to have to update in case they want any bug fixes. So in SpringSource Enterprise, we guarantee to provide bug fixes to our customers even if they're using old versions that are not really supported anymore by the community. The SpringSource Performance Suite contains a number of pieces of software that enhance the Spring experience. Of course, our support on Spring is unrivaled. It is backed by the people, like every significant Spring committer, and we provide a variety of SLAs that go down to the kind of things very large enterprises require. SpringSource Performance Suite offers 3 areas of functionality that build on Spring that make it easier to use and easier to manage. Firstly, the SpringSource Tool Suite. This is an Eclipse distribution that includes Spring IDE. It includes Mylan, which is a very interested task-oriented extension to Eclipse. It bundles a bunch of other plugins, and it also includes fairly significant amounts of code that are not available from us or anyone else in open source. So, this provides some of the value of something like My Eclipse, but it's kind of different in that it isn't actually taking things that other people develop, putting them together and putting a price tag on it. It's actually taking things that we and other people developed, adding very significant value, and then providing it under subscription. There are a bunch of features that are specifically oriented at Spring developers. So, for example, there's wizards or cheat sheets, as they're called in Eclipse. There's the ability to connect to our online services to find out potentially more information that we may have in our knowledge base about particular errors. And there is essentially an integrated environment for everything you need for Spring development. This is available for commercial use to our subscription customers, but it is also available for free for personal use for developers. So, for example, if you're using it for Big Bank, we would rather like Big Bank to pay. But if you're using it for your own personal use to improve your skills or do a hobby project or whatever, that's fine. SpringSource Application Management Suite. This is more aimed at Big Bank than it's aimed at you personally. This provides the ability to monitor production deployments. You get a bunch of metrics. Those metrics are exposed at a very deep level by instrumentation of the core Spring framework and other Spring portfolio projects. We do that instrumentation using Aspect-J. As I mentioned, we are now the leading committers in terms of Tomcat. We are also the leading committers in terms of Aspect-J. So SpringSource as a company is really extended quite a bit beyond Spring. Thirdly, if you're an advanced Oracle user, you may find the Advanced Pack for Oracle database of interest. This provides value-added integration to Oracle RAC clustering and also Oracle XML type handling and Oracle AQ, advanced queuing. One thing that we often see is that Oracle is pretty much the de facto standard in the enterprise. We see a lot of enterprises where Java developers are not taking advantage of the features of Oracle. There are a number of reasons for that. Some of them are cultural. Very often Java developers really don't want to work at a deep level with database features. Another is ideological. Java developers are kind of steeped in this idea that whatever you do must be portable between databases. And the third is ignorance, that very often Java developers simply don't have the skills to make effective use of the database. If you look at the second and third, they're actually pretty much the same thing. Anyone who thinks that a non-trivial application is portable between databases is, at least in my view, mistaken. If you look at the locking behaviors, if you look at stored procedure support, there are so many things that mean if you have a complex application, it is not going to be portable. I mean, I'm not talking about simpler applications like, you can write a shopping cart application that's probably totally portable. But if you have worked for a company that actually has spent its money wisely with $7 million on Oracle licenses, your applications are not going to be portable. If they're portable, they shouldn't have spent that much money on Oracle because they didn't need it. So if you're looking at Oracle RAC, for example, there are a bunch of things that you can get in terms of failover. So if a particular node fails, you can potentially retry an operation on another node if it's idempotent. You need to do that by looking at the Oracle exception and seeing whether or not you can retry. We provide that for you transparently. With the case of Oracle XML processing, it's not going to be completely transparent because you are going to be doing things that are Oracle specific, but they'll be very much easier with the Oracle integration that we provide. So our aim as a company is to provide a complete set of infrastructure offerings. SpringSource Enterprise spans development and production, as does the application platform. And on the production side, we have two Apache-oriented products. So we have support for Apache Tomcat and HTTP, and we bundle that into something called SpringSource Enterprise Ready Server, which is a subscription product that our Covalent division has supported over many years. We also, of course, provide training and consulting worldwide, but we are fundamentally a software company. We're a software company that's obviously making very, very large investments, both in Spring development and also in development of new products like the SpringSource application platform. Okay, that's all the slides I'm going to subject you to, so I'm very happy to take questions.
I had some questions about the Spring IDE and the dynamic modules. Do you add any support? One problem I've run into has to do with provisioning when you're developing. You're saying, in your manifest, some things you want on the server and you're going to load, but when you're developing, you're using, I don't know, Maven or something else like that. You guys got, I don't know, how do you handle that? Do you?
Yes, the duplication between OSGI at development in kind of build time and runtime is pretty annoying. There are some things that we do in the platform with that. So the SpringSource application platform actually can be provisioned from Maven or Ivy repo. In Spring IDE, I think it may be supported in SpringSource Tool Suite. Spring IDE itself doesn't have that much OSGI integration. We're also looking at providing additional things in future versions of the application platform that will make it even easier.
I have a question about debugging. So if there's an error in my annotations or my context files, what tooling is available to help me debug faster?
If there's an error in your context files, generally Spring is fail fast, so it's pretty specific. It will typically provide you information about the line number at which the error occurred. In annotations, there are probably, trying to think about annotation matching. If you had semantically invalid annotations, you would probably get a message when the container started up. I'm not sure whether or not Spring IDE would give you like gutter errors. I think SpringSource Tool Suite probably does. The best way really to validate your Spring configuration is to use the Spring integration testing support. This was introduced in Spring Framework 1.1.1. It gives you the ability to start up your Spring context and test things like data access and configuration processing without deployment to any other environment. We very, very strongly recommend that as a best practice. Again, if you look at the pet clinic sample application, you will see that in action. And that effectively, as a byproduct, very, very quickly checks your configuration. And you don't need to deploy to WebLogic or whatever you might be deploying on. So I strongly recommend you read the testing chapter in the reference manual. And really, that's one of the most effective tools for debugging your context.
On the Spring application platform, what kind of services or infrastructure does it provide to achieve, say, horizontal scalability, like the clustering that we traditionally do?
Currently, the clustering capabilities of the Spring Source application platform are equivalent to those in Tomcat. We don't provide anything in the platform beyond what Tomcat provides. However, in future versions of the platform, including probably a version released towards the end of the year, it will be providing more and more HA features. I mean, certainly our intention is to make this a platform that is highly scalable.
What's the state of REST support in Spring?
REST support for Spring will be included as a major priority in Spring Framework 3.0. It's going to build on Spring MVC rather than Spring Web Services. It will be probably the major feature in Spring 3.0 M1, which we should see in probably about 2 months' time.
Yeah, we'll do a raffle after the for QCon, and we'll also have an ID IntelliJ license.
I had another question for you. You've given a lot of good advice about best practices, like resources versus AutoWired. And I was wondering if you had a suggested book or a suggested site that's like the good parts and the suggested practices kind of resource.
That's a good question. Ultimately, we're doing quite a lot of work on the Spring community web properties. So we're going to try to carry more and more of that information on the .org site. We're in fact doing a relaunch of the .org at the end of this week. So hopefully we'll gradually get more and more up on the .org website. In terms of books, I'm probably haven't quite kept up with the books that are out there. I think Craig Walls' book is pretty good, and I think his latest edition is updated for 2.5.
And I found the online documentation to be excellent, so that you guys provide. So it's really good.
If you're building a Spring-powered application and deploying to Spring Source platform, I mean, you talked about a version conflict where BA WebLogic had to repackage it. So if I'm using a version of Spring, will it run on any version of Spring application platform? How does that work?
If you're using...
If I'm building a Spring-powered application, like I'm using a version of Spring today, and I want to deploy it to Spring application platform, so will there be any conflict kind of things?
If you're using Spring on the Spring application platform using the shared library WAR, there will be no conflict with any version of Spring. So you can specify, for example, that you're using Spring 2.5.4 and run it on a version of the Spring Source application platform that's based on Spring 3.0.
And it is GPL licensed, right?
The Spring Source application platform is GPL licensed. GPL licensing, of course, does not hurt end users. I think there's a lot of fear abroad in the Java community about GPL. It's interesting that I think it's a surprise to a lot of Java developers that 70% of open source software overall is GPL. So the reason that it's GPL is fundamentally, we think it's great that Spring Framework is used inside the WebLogic application server, for example. But frankly, we cannot afford to spend many millions of dollars building an application server that Oracle could just take. I mean, Larry Ellison is on record and as saying that we're not going to pay for open source things when we could just take the code. And Larry doesn't actually need more money. So I don't see why we should spend millions more dollars to give Larry Ellison more money. I mean, obviously, I'm just using Larry Ellison as an example. It applies to a number of companies. It's not aimed at a specific company. But the fact is that we are providing a huge amount of code under the Apache license, which is available to the IBMs and Oracles of this world, and they're using it, and that's great. But frankly, the Spring Source application platform solves a lot of problems that IBM and Oracle have been struggling with unsuccessfully for some time. And they can have the solution, but they can't have it for nothing. So we'd be delighted to partner with them. We'd love to license it to them. In fact, Richard works in business development. So
we also have a commercial version if you're a software company. There's a chance or a thought that you might want to look at this technology.
Yeah.
In conjunction with your application.
Yeah.
We have a
The important thing to note is that if you are developing applications that run on the platform, you are fine. Even Google is fine. If Google are running applications on it, it's not a problem for them. The only problem is that if you are a software company that is redistributing a product that you don't want to open source. If you want to open source it, that's absolutely fine. But if you want to profit by redistributing something that's closed above the application platform, you can't do it.
Can you expand a little bit more on the task-based workflows? Do you offer anything more than what Myelin offers? Or?
We are using the Myelin infrastructure as a basis to build on. So essentially what we're shipping is based on Myelin rather than extending the capabilities of Myelin itself. But we're tying it into, for example, providing cheat sheets for authoring particular Spring artifacts and different Myelin tasks that we ship out of the box to provide Spring-oriented benefits. The Spring Source tool suite is something that we are developing in our Vancouver office. We're also doing our development on Aspect J. We are working with TaskTop, the company behind Myelin, and in fact, we've contracted them to do quite a lot of work around the Spring Source tool suite. So it's very much a collaborative effort between ourselves and the developers of Myelin. That product is available free for personal use. So I'd certainly encourage you to get hold of it and evaluate it.
Great. I think maybe we should wrap things up now. And we got a drawing, like we said, for QCon, and also an idea IntelliJ license. And I'd like to thank Rod for his wonderful talk. And we've also got a new representative back in the back here, Jeremy Mason. He's helping us out with the room and going to make sure we have pizza next time and the tapings and all that. So, but he just started like a couple days ago, so don't blame him this time. But next time, it'll all be there. So,
Thank you, Jeremy.
Yeah, special thanks to Jeremy.